About projectile motion. Projectile motion is a two-dimensional motion. It is a motion under gravity. One of the components is affected by gravity. One of the two dimensions is affected by gravity while the other is not. Motion, it is a motion that has two parts, one in the x direction and the other in the y direction, meaning the horizontal direction and the vertical direction, horizontal and vertical directions. Okay, so x and y are the two directions in which the projectile motion proceeds, the two components of the projectile motion proceeds. It is Projectile motion is observed in objects that are thrown at an angle to the horizontal. What this actually means is that if, for example, I have some ball over here and I throw it with an initial velocity v at an angle theta to the horizontal ground, this v velocity, being a vector, will split itself, it will resolve itself into two components, into the two rectangular components of a vector. One is the horizontal component while the other is the vertical component, exactly perpendicular to the horizontal component. There is a 90-degree angle in between the two components. The horizontal component is known as v cos theta. This can be calculated by v cos theta, v being the velocity, and cos of the theta, the cos of the angle, will give us v cos theta, the horizontal component. It is responsible for the horizontal motion of the projectile. It remains constant throughout the motion, because the horizontal acceleration in projectile is zero. Therefore such a motion is known as uniform motion, in which the horizontal component of the projectile does not change. The horizontal component of the velocity does not change throughout the motion and remains constant. So a horizontal component is the constant component of velocity, whereas the vertical component can be calculated by v sine theta. This is responsible for the vertical motion throughout the projectile, and it undergoes a uniformly accelerated motion because the acceleration in the vertical direction is constant and is equal to the acceleration of free fall, which is 9.81 for Earth. 9.81 meters per second squared. These points are very important points to remember because these are the basics of the projectile motion. If you understand these well, then projectile motion will become quite easy to understand. So the takeaway points are: the horizontal velocity, the horizontal component of velocity is v cos theta, which remains constant throughout the motion, and its magnitude also remains v cos theta, constant at v cos theta. And because the acceleration is zero, the vertical velocity, it undergoes uniform acceleration of 9.81. Now let's look at projectile motion in a bit more detail. Over here I have a ball. I throw it with a velocity v at an angle theta. This is the angle theta. So now this velocity will split into two components, the horizontal component and the vertical component. The horizontal component is right adjacent to the angle theta, v cos theta, while the vertical component is right opposite to the angle theta, v sin theta. The horizontal component, now the horizontal component will remain constant throughout the motion. So v cos theta, v cos theta, v cos theta, at every point the horizontal component will have the same value of v cos theta. The magnitude does not change. Whereas the vertical component, on the other hand, will undergo uniformly accelerated motion, and its acceleration will vary in similar to the acceleration of this motion, or to the acceleration of this ball that is thrown vertically upwards with an initial velocity of v sine theta, which is actually the vertical component of the projectile. It is thrown with a velocity of v sine theta. Now going upwards, this ball, the velocity will start decreasing because acceleration is directed downwards, and that acceleration is basically negative. So for the upward motion, the acceleration is negative and the velocity of the vertical component decreases, and at the maximum height becomes equal to zero. So this vertical component initially was maximum, and as the motion proceeds, its value starts decreasing as shown by the height of the arrows. The height of the arrow is decreasing and decreasing, and finally over here, the vertical velocity becomes zero and only the horizontal component of the velocity exists. So this means that at the maximum height, the resultant velocity is actually equal to the horizontal component of the initial velocity. The resultant velocity is equal to the horizontal component of the initial velocity with which it was thrown. Now, in the motion of this ball returning downwards, the velocity now starts increasing its magnitude, increasing in magnitude, and it starts increasing in the opposite direction, in the negative direction. So similar is the case here. Initially, the vertical velocity was zero, and its magnitude starts increasing in the negative direction. So because the acceleration is also downwards, so acceleration is positive for the downward motion. This actually increases the magnitude of velocity in the downward direction. So the horizontal component has zero acceleration because velocity is not changing. The horizontal component of velocity is not changing. The vertical component has a constant acceleration of 9.81, due to which its velocity constantly changes, similar to the motion of this ball that is thrown upward and then it returns back. Okay, so this is a very important part of the projectile motion, and a lot of questions are asked from here. This maximum height, this h, is known as a maximum height, and the horizontal distance, the maximum horizontal distance that the projectile covers, is represented by r and is called the range of the projectile. This is known as the range of the projectile. H is known as the maximum height of the projectile. The shape of this path is parabolic. Parabolic. Okay, now let's look at the equations that are applicable on the two types of motions, on the two parts of the motions of the projectile, the horizontal part and the vertical part. The horizontal part remains constant, so it's uniform motion, and the only equation of motion that is applicable is S is equal to Vt, where S represents the displacement, V represents the velocity, the horizontal component of velocity actually. So this should be V h actually, the horizontal component of velocity, which is v cos theta, and the time it takes for the ball to move. Okay, and the t represents the time. It is applicable because acceleration is zero and it's undergoing uniform motion. Whereas on the vertical component, all equations of motions are applicable because acceleration is constant, equal to 9.81, and hence it's uniformly accelerated motion, and all the equations of motions are applicable on uniformly accelerated motion, as equals to ut plus half at squared, v squared equals u squared plus 2as, s is equals to u plus v upon 2 whole thing multiplied by t, and v is equals to u plus at. We've covered all this in the previous videos. So this is all about the basics of projectile. In the next video, we'll start off with a few questions, and we'll do half projectile motion. Okay, so thank you.